Before we get to the story, I'd like to say thanks so much for visiting my new channel. I'm going to be uploading cosmic horror related stories every single day. So if that sounds good, please drop a like and don't forget to subscribe. It means a lot, especially when just getting started. I hope you enjoy the story. Hydrology is a profession built on the assumption that water follows rules. It flows downhill, it fills available space, it moves according to pressure and gravity and the shape of whatever contains it. In 15 years of freshwater survey work, I had never encountered water that didn't follow those rules, and I had worked in some genuinely strange places: old mine flood zones, collapsed karst systems, reservoirs built over geological features that made the engineers nervous. Water always behaved. It always made sense once you understood what was underneath it. The reservoir outside Tullen, Oregon, broke that assumption so cleanly and so quietly that it took me several days to accept what my equipment was telling me. My name is Reed, and I do freshwater assessment and reservoir survey work on contract for water authorities, municipal systems, and occasionally private landowners with large enough bodies of water to need professional attention. The Tullen Reservoir was a mid-sized impoundment in a valley about 40 miles from the nearest town of any size, built in the mid-50s to serve a rural water district that had since grown larger than anyone in the 50s had anticipated. The water authority that managed it had been dealing with irregular pressure readings in their intake system for about 3 months and had exhausted their in-house explanations. They brought me in to do a full-depth mapping survey and assess the intake infrastructure from the water side. It was supposed to take a week. I billed for a week. I ended up staying for most of 3. The valley the reservoir sits in is the kind of place that looks the same in every direction. Low ridges covered in second-growth fir, a gravel road running down to the water authority's maintenance dock. No development visible from the water surface. Quiet in a way that's almost aggressive. I've worked in remote areas before, and the quiet there doesn't bother me. The quiet at Tullen was different, though I couldn't have told you why at the time, and I'm not sure I can now. It was just the kind of quiet that made you aware of it. The water authority's contact on site was a field worker named Guest, a thin and practical man in his 50s who knew the reservoir the way people know places they've worked for a long time. Not with any sentimentality, but with the specific, detailed knowledge that comes from daily maintenance. He met me at the dock the first morning, showed me the equipment shed, gave me the keys to the authority's survey skiff, and told me if I needed anything, he'd be at the pump station about a mile up the access road. I asked him about the pressure readings, the irregularity that had prompted the call. He described them in technical terms, and then, when I asked him to put it plainly, he said the intake was behaving like something was pulling on it from below. Not a blockage, not a mechanical fault, more like a draw. He'd reported it 4 times, and 4 times the engineers had come out, run their checks, found nothing wrong with the equipment, and gone home. I asked if the draw was consistent. He said it was stronger in one area, near the center of the reservoir. I thanked him and went out on the skiff. Depth mapping is methodical work. You run the sonar unit in parallel passes across the water surface, building a picture of the bottom profile the way a printer builds an image, line by line. It takes time, and it's not exciting, but it's precise. and at the end of it, you have a three-dimensional map of the lake bed that you can compare against the geological surveys and the original engineering records to confirm that everything is where it should be. I ran my first pass on a Tuesday morning, starting from the northern shore. The reservoir had a documented maximum depth of about 80 feet in the original construction records, consistent with the valley floor profile established in the bedrock survey done before the dam was built. My sonar was more than adequate for that depth range. Everything came in normal for the first 2 hours. The bottom profile matched the historical records. The intake structure read clean. The sediment layer was what I'd expect for a reservoir of this age. I was most of the way through the survey grid when the unit returned a reading I'd never seen before. No bottom signal. I'd had sonar units fail to return a signal before. It happens when the unit malfunctions, when there's excessive turbulence scattering the pulse, or when you're working at a depth that exceeds the unit's rated range. None of those conditions applied here. The water was calm, the unit was functioning correctly by every diagnostic indicator, and we were nowhere near the rated depth limit of the equipment. I circled back and ran the pass again. Same result. A single location, roughly central in the reservoir, where the sonar pulse went down and did not come back. I marked the coordinates and kept going. I finished the survey grid and went back to the dock and pulled the data and looked at it for a long time. Every other location in the reservoir had a clear bottom reading. The depths were consistent with the records. The bottom profile matched the valley floor geology almost exactly, except for that one spot. The next morning, I swapped out the sonar unit for the backup I kept in my equipment cases. Different manufacturer, different frequency, calibrated separately. I went back to the coordinates and ran the pass 3 times. Same result. No return signal. I sat in the skiff for a while after the 3rd pass and thought about what that meant in practical terms. A sonar pulse travels down through the water, hits the bottom, and bounces back. If it doesn't bounce back, either the bottom isn't there or the bottom is so far down that the pulse dissipates before it can return. My unit was rated for 600 feet. The documented bottom at those coordinates should have been less than 90 feet down. The pulse was not returning from 90 feet. It was not returning at all. There's a method for checking depth without electronics that's older than sonar, older than most technology people associate with water work. A weighted line. You lower a weight on a measured line until it hits bottom and you read off how far it went. Simple, reliable, not subject to equipment failure. I had a 300-foot sounding line in my equipment cases, which I'd never needed for reservoir work because no inland reservoir I'd ever surveyed came close to requiring it. I motored back to the coordinates, cut the engine, and let the skiff settle. The water at the surface was a dark greenish brown, the normal color of a mid-aged reservoir with healthy algae levels. It looked like every other part of the reservoir. I dropped the weighted end of the line and let it run through my hands. At 100 feet, the weight was still dropping. At 200 feet, it was still dropping. I let the line run all the way out to 300 feet, and there was no contact. The weight was hanging in open water somewhere below me, 300 feet down, and it had not touched anything. I pulled the line back up and coiled it and sat in the skiff and looked at the water. Guest was at the pump station when I drove up the access road that afternoon. I asked him about the survey drones the authority had mentioned losing in previous years. 2 units, according to the contract paperwork, both attributed to equipment failure. He leaned against the pump station wall and looked at me in a way that suggested he'd been waiting for someone to ask. Both drones had been lost in the same general area of the reservoir, he said. One 2 years ago, one the year before that. The operators had been doing routine inspection passes when the units went down and didn't come back up. The water authority had written them off as battery failures, which was the explanation that fit the paperwork best. Guest said he hadn't argued with it at the time because he didn't have a better explanation to offer. I asked him if either drone had been recovered. He said no. I asked where specifically they'd gone down. He pulled out his phone and showed me the incident reports he'd filed at the time. The coordinates were within 40 feet of the location I'd been mapping all day. I spent an evening in my truck going through the documentation the water authority had sent me before the job. The full project file, including the original construction records from the 50s, engineering surveys, geological assessments, correspondence between the dam builders and the water district, old documents, some of them scanned from physical copies and hard to read, but complete enough to work through. The geological survey done before construction showed the valley floor at a consistent depth across the impoundment area, a shallow bedrock profile that made the site attractive for reservoir development in the first place. 90 feet or less to bedrock across most of the valley, with a notation about one location near the center where the survey team had recorded a feature they described as a potential sinkhole risk, a place where the ground-penetrating readings had been inconsistent. The notation recommended further investigation before construction proceeded. There was a response letter from the water district dated 2 weeks later, directing the engineers to proceed on schedule. The response letter cited budget and timeline constraints and noted that sinkhole risks in the region were common and typically stable. The further investigation was never done. Whatever the survey team had found in that spot in the early 50s had been noted, flagged, and then set aside because it was inconvenient. They'd built the dam and filled the valley with water, and the inconsistency at the center of it had been sitting underwater for 70 years. I drove back out to the dock the following morning with a different piece of equipment, a camera on a cable reel, the kind used for inspecting dam faces and intake structures at depth. It had a rated depth of 250 feet and a low-light sensor that worked reasonably well in freshwater conditions. I didn't have anything rated deeper than that with me, and getting something better would have taken a week to source. I motored out to the coordinates and anchored the skiff, which took longer than usual because the anchor wanted to drag, not with any current, just drifting consistently toward the center point before catching. I let out extra line and it held. I dropped the camera on its cable and watched the feed on the monitor mounted to the skiff's console. The footage was what you'd expect for the first 100 feet. Greenish water getting darker, some suspended particulate, the occasional fish moving through the frame. Normal reservoir water column. Past 150 feet, it was very dark, and the low-light sensor was working hard, and the image was grainy, but still resolving. I could see water. I could not yet see a bottom. At 200 feet, the image changed. I've thought a lot about how to describe what the camera showed at that depth because I want to be accurate and I don't have great language for it. The water column above it was water, clearly, recognizably. What the camera crossed into at 200 feet was not rock and not sediment and not any transition I had a category for. It wasn't dark in the way deep water is dark. It had a quality to it that the camera seemed to struggle with. The image going inconsistent, the low light sensor returning values that didn't correspond to anything I'd seen it return before. The camera crossed into it. The feed held for about 4 seconds and then went to static. I tried to retrieve the cable. It came up slack. All of it, reeling in with no resistance, the way a line comes in when there's nothing on the end of it. I pulled it all the way up and looked at the end. The cable end was clean, not frayed, not corroded, not damaged in any visible way. It had a clean termination, like a cut, except there was no cut mark, and the end cap that held the camera housing was gone, along with the camera itself. The cable simply ended where the camera had been. I looked at that end for a long time. Then I pulled up the anchor and went back to the dock. I called the Water Authority's project manager that evening and gave him a verbal summary of what I'd found. I used careful language. I described the sonar anomaly as an unresolved depth reading, the sounding line result as inconclusive bottom contact, the camera loss as equipment failure under unknown conditions. All of those descriptions were technically accurate. None of them came close to what I actually thought was happening in that reservoir. He asked me what I thought was causing the pressure irregularity in the intake system. I told him there was a feature at the center of the reservoir that was drawing water downward with enough force to affect the intake infrastructure, and that the feature was of undetermined depth and origin, and that I was recommending the area be flagged as a safety exclusion zone pending further study by a team with appropriate deep water equipment. He asked me how serious I thought it was. I told him that 2 survey drones and 1 camera unit had been lost above the same coordinates, that no piece of equipment I'd lowered into that spot had come back, and that my professional recommendation was to treat it seriously. He thanked me and said he'd discuss it with the board. I spent 2 more days on site, finishing the parts of my survey that didn't involve the center of the reservoir, getting the full depth map completed and the intake infrastructure documented. I went back to the coordinates once more, on my last morning, without any equipment. I just sat in the skiff and looked at the water above that spot and thought about the survey team in the 50s, the ones who'd flagged it and been told to proceed anyway, and about the 70 years of water sitting on top of whatever they'd found. The surface looked completely normal. There was nothing to see. A little chop from a light wind, the same dark water as everywhere else. You'd never know from looking. That's the thing about that spot that I keep coming back to. Everything that went into it went quietly. The drones, the camera, my sounding weight hanging in open water at 300 feet. No disturbance, no visible draw, no indication from the surface that anything was different there. Just depth, where depth shouldn't be, and a consistency to the losing of things that went past coincidence a long time before I arrived. I filed my formal report 10 days after leaving the site. It was thorough and it was specific, and I included every measurement and every equipment result, and my recommendation that the area be restricted and assessed by a specialist team with deep water rated equipment before any further work was done on the reservoir. The Water Authority acknowledged receipt and told me the report would be reviewed at the next board meeting. 3 weeks after I filed it, I got a call from Guest. He didn't call me often. He wasn't a person who called unless there was a reason. A contractor's boat had gone missing on the reservoir, he said. A 2-man crew doing some unrelated infrastructure work near the dam face. They'd been working in the morning, and when the afternoon check-in didn't happen, someone went looking. The boat was gone, not sunk, or at least nothing visible on the surface. No debris, no equipment floating, nothing. The 2 men were gone with it. I asked Guest where on the reservoir they'd been working. He was quiet for a moment. Then he said the last recorded position from their check-in that morning had them near the center. I thanked him and sat with that for a while. The Water Authority closed the center section of the reservoir to any boat traffic shortly after. No announcement, no public statement, just a buoy line placed around the exclusion zone and a note added to the contractor access documentation. Quietly done, the way things are done when the people doing them would rather not discuss the reason. The follow-up contract offer came about a month later. A different point of contact this time, a name I didn't recognize, with a request for a second assessment using, as the email put it, more specialized equipment sourced by the authority. The money was good, better than the first contract. I didn't take it. I've thought about why, and I think the honest answer is the cable end. Everything else I could put in a professional framework, anomalous sonar readings, inconclusive depth measurements, equipment lost to undetermined causes. Those things have professional language around them, and professional language creates distance, and distance makes things manageable. The cable end didn't have professional language. A frayed cable means something pulled or abraded it. A corroded end means chemical exposure over time. A clean termination on a steel cable with no tooling marks and no camera attached means something I don't have a framework for, and I've stopped trying to build one. What I know is that below the surface of a rural reservoir in Oregon, at a spot that a survey team flagged and a water district ignored 70 years ago, there is something that goes down further than my equipment can follow and takes whatever is lowered into it without returning any of it. It affects the pressure of the water around it. It draws things toward it across open water. It has been sitting under that reservoir since before the reservoir existed, since before the dam was built. And the dam and the water and the 70 years haven't changed it at all. I don't know what it is. I don't know how far down it goes. I don't know if it's a geological feature that behaves in ways geology shouldn't, or something else entirely, something that was there before the rock above it and will be there after. I know that 2 men went out on that water above it and didn't come back. I know the buoy line is still up, and the exclusion zone is still in place, and the Water Authority is still managing a reservoir with something in the middle of it that nobody wants to name directly. And I know that wherever that sounding weight ended up, 300 feet down in water that shouldn't exist under an Oregon valley, it's still falling. I think about that more than I should.